Congratulations, you've now finished the first part of the unit about forces, and you're ready to move on. Before you get going, there's one last problem you should do. Try to solve this problem. It's going to incorporate most of your knowledge of forces so far, so you're going to have to remember all the things we've covered. So for this problem, imagine that three people decide to play tug of war. And however, because they're different, there's only three of them, they can't form even teams. So they decide they're going to play tug of war by tying three ropes together, like this. And each of them is going to pull on one rope. And the goal is for them to keep the ropes centered. So the person pulling on this rope is going to pull with negative 10 newtons in the x direction, plus 5 newtons in the y direction. The person pulling on this rope is going to pull with 8 newtons in the x direction. And the person pulling on this rope is going to pull with some number of newtons in some direction. So we don't know what this force is. We're going to call it force 3. So now go ahead, draw a free body diagram. Remember to include what the acceleration is going to be, and then try to solve for force 3. Figure out how many newtons of force it is in what directions. And you can go ahead and pause the videos, and then when we restart, I'll go through the answers. Hopefully you had some luck solving this. We're going to go through it step by step. Let's start by drawing the free body diagram. Here's the center. Here are the three ropes. We don't actually know what direction this is, but we'll just draw it in some direction for now. And we'll call these force 2, force 1, and force 3. I already wrote them out, so I'm not going to write them out again. And now we need to remember to include what the net force is. We know it's not accelerating, so the net force is 0. And as a result, we can say that force 1 plus force 2 plus force 3 equals 0. So let's actually add those together to get a better idea of what's going on. That says that negative 10 newtons in the x direction plus 5 newtons in the y direction, plus 8 more newtons in the x direction, plus force 3 equals 0. We can subtract some of these terms from each other. Negative 10 plus 8 is negative 2. So negative 10 newtons in the x direction plus 5 newtons in the y direction plus force 3 equals 0. Now let's subtract force 3 from both sides. And that'll leave us with negative 2 in the x-hat direction plus 5 in the y-hat direction. The unit's still newtons, but I shouldn't feel like writing it out again. Equals negative force 3. Multiplying by negative 1 gives us 2 in the x-hat direction minus 5 in the y-hat direction equals force 3. And that means he's going to have to pull roughly in this direction to balance out the other two forces. When we look at it, that makes a lot of sense. That seems to create a fairly balanced triangle of forces. So hopefully you can see how that works. We're just subtracting the forces from each other and adding them and getting them all to cancel out to 0. And we knew the net force had to be 0 because the acceleration is 0. And if we had an acceleration that was a net force, then we could just treat the object as being forced by that force, and they would have to accelerate in some direction. As you understand this, then you've successfully understood this unit, and you're ready to move on to understand Newton's laws. If not, don't worry. Go back, rewatch the videos a little bit, and hopefully you can get a better grasp of what's going on.